TPA3255 for multi-channel amplification. At year 2025, audio amplifiers exceed in level that quality exceeds human hearing threshold for about 100 times. That means that many companies, many designs, many amplifiers in a market which sounds equal, even they have slight difference in technical parameters and some services, the overall technical performance is excellent, and they can drive any speakers what you have. The key differentiator is a maximum power, but not a quality. And what next? Practically for any money we can't buy better quality. No way. And the next logical step is multi-channel amplification, or use a different architecture. Architecture when crossover for speaker band separation is done before audio amplifier, and audio amplifier output is directly connected to the speaker. In that case, we need multi-channel audio amplification, that we need audio amplifier for each speaker. One for tweeter, one for mid-range, and one for woofer. When woofer is power consuming and mid-range and tweeter needs a quality. Why we get a better quality with a multi-channel amplification? And here is an answer. You can see here's a great large floor standing speaker from Troels Gravesen designs, and here is a passive crossover for that speaker. And you can see, especially for the mid-range, for three-way speaker mid-range, we have plenty of high power components in series with the speaker. And imagine, here we have damping factor of 800, but mid-range speaker is sensing about 0.5 damping factor. Because we have tons of losses, and practically amplifier is not controlling that speaker, and all speaker quality is defined by suspension system. Electrical we are not controlling. And the moment when we move amplifier here on the speaker input, we have full control of this speaker. And damping factor here is 800, and we have electrical perfect control. So the precision of this loudspeaker rises several times. And the main reason for audio amplifier is precisely drive speaker. And then we have the detalization tolerance, that when we put it here, we have a blurry audio signal. Maybe we put it here, it's sharp, precise, it works at a low volume. And this is the largest gain what we can get, it's largest improvement in audio quality. And the same for tweeter and also for a woofer. Mid-range has the highest impact. I'm not talking about phase distortions, about quality of each component, etc., etc. It's a secondary question. And you can see this is a practical implementation of passive crossover. There are high power resistive components, 20 watt component here, 20 watt component here, about 10 watts here. Then we have plenty of windings. We have a metal core here, which can saturate at high power. We have a ferrite core here, and in the forums you can find plenty of discussion about each component quality, how they impact the sound, and it's better to get rid of it. It's not a better, it's a must to get rid of it, really, to go on the next quality level of your speaker reproduction system. It's not an amplifier. We need that speaker could be driven at maximum possible quality. And here you can see how much R&D is necessary to build such a speaker. Troels designed it, and then had several components and testing. It takes significant human hours, and you need to have a number of stock components that you can do variations. You do calculation, then you measure, and then you do some modifications, and finally you get more or less okay system. But then the system is binded to specific loudspeakers in your loudspeaker system. You can't exchange it. You can't exchange different type of loudspeakers. Then you need to recalculate and rebuild a crossover. So generally not a great solution. And why we need large floor standing speakers for a music? we should fill a room, and even for a 20 square meter non-treated room, for a good audio reproduction, you need a pretty large floor standing system. Could you use a small 6-inch system for a 20 square meter listening room, listening at 2-3 meter distance? No, they will sound crappy as a plaque. Where to use 6-inch two-way speakers? You can use them in near field areas. That means if you are sitting on a table and then on a 1 meter distance you have near field monitors, they will sound awesome. When you put in large rooms, they will sound crappy, and then you need the larger speakers. Also, for a non-treated room, a good solution is that you put in a wheels when you're listening background music, somehow low level. You keep them in the corners, and when you really want to listen high quality, enjoy each bit and piece of the music, then you move it to the right place, because in non-treated room there are not many positions how you can put the speakers, and then you listen maximum quality. When you finish, then you put back in the corners, and they serve as a furniture. Another big market in favor of multi-channel system or active speaker system is your capability modify old speakers. There's a big market from the 70s, 80s and 90s speakers. It's a secondary market. And with a slight modification, you can get incredible quality. Typically, 70s, 80s and 90s struggled in the mid-range and tweeter part due to the lack of CNC machines. And in a modern industry, we have CNC machines everywhere. Our tolerance and capabilities to design something small and precise is incredible, with a high repeatability, and modern speakers has a better glues, better chemical compounds, better paper sandwich compounds, better type of materials for speaker cones, many things. Better magnets, better and stronger magnet configurations. So when we replace mid-range and tweeter, we really replace the most sensitive part of our hearing, and we get by far better audio reproduction. But when we are replacing those parts, we should engineer crossover, which is difficult or almost impossible for the eye guys. And in that case, active system solving that issue, we can remove passive crossover, just put speaker outputs on a backside of that old speaker. And if your woofer is good, and in majority cases woofer is good, you just check a physical damage presence, and if there is no physical damages, you can buy really good woofers. And particularly this woofer has a 12-inch size, and it is 30 watt rated woofer with a 50 watt capability, but it has high sensitivity and sounds incredible in that box. So this modified speaker sounds awesome, really it's really good, and I'm listening it for 2 months and can't stop listening it. And the costs are relatively small for in a modern world. For 50 euros you can buy very good speakers actually. I have a separate video how I did the modifications, and then you have a German speaker MSH 116 here, and this is kind of SB acoustic speaker. Both are good manufacturers, and you can buy those speakers in retail. And this is a moment when TPA3255 comes on a stage, and here is a multi-channel version of that power amplifier. And this cheap TPA3255 actually is closing the gap what we had, and it's absolutely great for multi-channel amplification solutions. And there is a one which I tested. I also have a separate video about that, and it's built by the book based on a reference design. It has balanced and unbalanced connection option, and you can set it with a jumper. That gives additional flexibility. Maybe some limitation is that you can go with a maximum power of 300 watts for that particular chip. Due to the heatsink size, you need active cooling, but you can get honest 200 watts out of that board. And here you have 4 channels, 4 times 200. It's a decent power for a great multi-channel amplification system. And how this system would look like? Here is a TPA3255 specs. A lot of great things written. Those who are addicted to total harmonic distortion, you can see it. Double zeros after comma and some figure. Actually, by quality, it is absolutely perfect. But let's take an attention to the drawing, total harmonic distortion. I will put it a bit larger for different loads. And you can see for 4 ohm we can get at max about 200 clean powers. That practically by adding power there is no more total harmonic distortions, and then from 200 watt it goes up. This is important for a woofer, because woofer is the only one who demands large power. And but there is a good news that when you separate bands in front of audio amplifier, then one amplifier is working just for a woofer, and for a woofer human hearing has low sensitivity to total harmonic distortions, because woofer driven at such power has self distortions 15-20%, and we still feel that it's nice round bass. We don't hear those distortions. And for a tweeter and mid-range, when we have separate amplifiers, we are working at in this region between 1 and 10 watts. We have plenty of headroom, and then even woofer is at a clipping level. We have super clean mid-range and the tweeters. This is the advantage of active speaker systems, that we have perfect this sensitive region part, and it gives it so clarity in all detail and all instruments that we feel that audio quality improves so many times. An additional advantage of multi-channel amplification system, that we can separate amplifier driving woofer from amplifiers driving mid-range and tweeter. Huge advantage. When we're running with one amplifier, we need a really powerful, in our case probably for to get a similar quality, we need at least 500 watt amplifier to work away from clipping and drive woofer and still have a low total harmonic distortions for a mid-range and tweeter, or for overall system. And let's think together what kind of system we can build, or what kind of configurations we can build from those boards. This is how they look in real life. My boards came without jumpers, and I made by myself. And then I ordered from AliExpress, but who knows, it will take some time when they come. So that was kind of little disappointment. The jumpers were not included. Small thing. Easy to solve, but anyway. And one of solutions would be that we can put a system in 1U rack. The height is right for a 1U rack mount size, and that will give a flexibility to use a professional equipment. And also you can find a power supply which also fit in 1U rack size. And then it could be kind of such type of solution. Let's imagine that here is the front and here is the back, and if you put connectors here, 8 connectors, then we have a short distance to inputs, and we can use unshielded wires. When you use unshielded wires, we are saving human hours. Someone would say that it's bad design, there is no shielded wires, but you know, when you peel shielded wire in both sides, then those clean wires will be longer than using unshielded wires. And in this case, when you use unshielded wires, we have a better noise signal to noise ratio than using shielded wires, and we are saving manpower. It's important as well to get a good price performance. What is the drawback of such design? Drawback is that we don't have airflow, only environmental heat dissipation. There is no chimney. You can see all ribs should be in this way that have a chimney. But I tested it, it's working. Unsafe power supply voltage is 42 volts, not 48. With 48 we are going above 60, 65 and close to 70. It's not good, because there could be also some hot summer conditions when environmental temperature can go up to 30, 35 degrees, and then we can run in trouble. But honestly saying, this chip is capable to work up to 120 degrees Celsius of chip temperature, and typically between heatsink and crystal difference is about a 20 degrees. That if it goes to 70 degrees, then crystal temperature will be about 90 degrees, and you have significant margin. Yes, and strictly talking, it can safely operate up to 85 degrees of Celsius of heatsink, but then it's not healthy for electrolytic capacitors, and you have plenty of them here. The life cycle of extreme operation will shorten maybe from 10 years to 3-5 years, and it is better to work not above 42 volts power supply for that flat configuration. But then it's safe, and you get a clean 200 watt power out, and it's plenty of power for active speaker system. What else can we make? There is better solution, thermally better solution. If we put boards in this way, yeah, then we have a chimney. The height is 130 millimeters, and then there's a nice chimney, great airflow, and then all those boards are cooling well. Also, you will gain some compact volume. The box may look ugly, but from engineering point of view it will be great. And this is alternative how to make, and I will at the end of this video will ask you evaluate which design you prefer. All of them are secure to work, no complaints. Technically they will be perfect, but just to having some market research which one you like, I would like to get your opinion in the comments if you can. Practical implementation. Here is one new unit together with professional crossover. Those professional crossovers are produced in large volumes. Those are almost perfect designs, and you can easily change the crossover frequencies. Again, for each speaker you can work with the different speaker systems, test them, and I really recommend before you buy expensive digital crossovers, etc., to test the system with a budget analog 3-way crossover, what you can buy in professional shops, and those will be great. Also, then you can use professional patch cables. You can get 8 pieces below 20 euros. Those are very good quality, very good contacts, flexible, reliable, produced in large volumes, and you have a small investments for that, much smaller than using some consumer cables. There is a couple of limitations due to the backside size. You can't put 8 separate speaker outputs. You should use some combined proprietary connectors. Those are speak-on 8-pin connectors, but for audio system it's great because you never make mistake. It's a one-click connection, one-click disconnection for multiple connection purposes built. Excellent solution. I like it very much. And then here inside that protective cover you have 8 pairs of speaker cables. One more thing with the 8 channels and 3-way system. For example, if you have a woofer with the 2 coils, and there are woofers with the 2 coils, 8 plus 8 ohms coils, and you can make a different configuration, or 4 plus 4 coils that you can make a different configurations, and then you can use that extra amplifier to double woofer the woofer power. Also good solution, and also it's a good solution for the subwoofers as well. How does it look inside? Highly optimized design, a very short distance from input connectors to board, optimum length of wires, and of course you need a good power supply. And you can see, as I mentioned, one drawback of that or one simplification of that board is that onboard electrolytic capacitors or storage capacitors are small, and here I put high quality, very high quality 10,000 microfarad low internal resistance capacitor to double peak power capability. And then we need a power supply, and the best power supply for audio equipment is a resonance type or LSC type power supplies. And let's quickly look what this architecture means. Here is a resonant type switching mode power supply principal schema. You have some kind of switching mode power supply, but there is one specific. You can see here is the serial resonant circuits, and what happens through the main transformer, what we have here is a pure sine wave current, and it reduces switching mode power supply noise significantly, and it's the best architecture for audio amplifier. The second advantage of such kind of architecture is that this switching mode power supply works very well with a variable load or a variable power. And you know, when with the music that typical pattern is like a tidge, the bass 70 watts, and then you have some la 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 or some instruments, and then there is a 1 watt or 2 watt or 3 watts, and it works that tidge tam la 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 tidge ta la 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 la, and this is kind of pushing and pulling that switching mode power supply, and it works very well with such kind of load. Normal flybacks and other type of architecture doesn't work well with such type of load. Here's the principle how regulation happens. Here you have a resonance, and at a resonance those circuits are becoming like a short, no resistance, and all energy is flying through the transformer. And if you have a frequencies away from the resonance, then those circuits has a resistance. And here it is shown at a heavy load we are working close to the resonance. At light load we are going away from the resonance, and by changing just the frequency, not the pulse widths and other stuff, we are regulating output voltage, and it regulates so well that even at a heavy load, this is a rock solid 42 volts or 36 volts out, and they are not jumping up and down. And for Class D amplifiers it's important, then you get the maximum quality. And for practical implementation there is one drawback for resonant type of power supplies. The regulation can go in very broad region, and you can have only either 110 volt power supply or 220 volt. You can't cover full region, and then you can solve it by adding so-called PFC circuits or phase corrector, and those are requirements for high power power supplies in the European Union, in America, because then you're making those switching mode power supplies changing from capacitive load to the mains to inductive load, which is important and efficiently use network, and then this PFC is making stable voltage in output like a 400 volts, and then resonance part is working well. I designed such power supplies in the past, and those are really excellent. Just for to recognize some known elements. It's a complicated schema, but for example, here you have this resonant inductivity, and you can wind in specific way that main transform in a way that you don't need a separate element. And here you have that resonance capacitor. You can see that it is high power capacitor because the power what this capacitor can handle is capacity multiplied by voltages, and then all this system works excellent. It's the best possible architecture, and now we need to find one, and here it is. Meanwhile, it is good manufacture, and this is medical grade power supply. It has a resonance tank here, and it has a PFC, and it is rated for 300 continuous watts and 450 watts in a peaks for 3 seconds, which is far more than one base. And with a good capacitor, you can double peak power. And this small power supply, small footprint power supply, can deliver 800 watt peak power, what is more than we need for our system to really drive it at a maximum possible quality and we get an excellent bass out of it. As I mentioned, it's a medical grade power supply, very well protected, absolutely great power supply. Yeah, it's maybe double to the mainstream, but it is certified in all countries. Those are produced in large volumes, and I recommend to use it for such type of boards, and those are excellent, really excellent. For that system, I'm using 36 volt version because the step is 36 and then 48. And 36 you can regulate up to 39. With 39 we get out about 180 watts from that board amplifier, and you can imagine it's a plenty of power, especially when you drive your system directly connected to speakers. Alternative could be if we put boards vertically. And you can see if we put board vertically, we have inputs and then we have outputs. Also, we can do modifications. For example, we can use consumer type of inputs and configure board accordingly. We can put here banana type inputs. We can do several configurations. And let's look to practical implementation. Here you are, the same as on picture. Let's check quickly dimensions. 25 centimeters width, 14 centimeters depth, and 13, okay, with the feet, 14 centimeters height. Pretty okay. You can put in different places, and that's easy to install. This design is making great chimney between bottom and top. In the bottom, cold air is coming in and hot air is coming out. And when temperature rises for the boards, this process accelerates, and it is very good from the cooling point of view. With this solution, you can use 48 volt power supply as well and get more power if you need, but you really should understand why you need it. Otherwise you are heating environment. And this is idle losses, that most of the heat what is coming is not because you are playing loud. It's because those are idle losses what happens just for efficiency of the system, and by specs each chip creates 2.5 watts, and here you have 4 chips in a box. You have 10 watts from just a chipset, and approximately the same you get from inductors. They also becoming hot. There are losses in inductors. And I checked, total losses using 48 volts power supply is 17 watts. And that's kind of a bit too much. And when you reduce a power supply to 42 volts, it's about 15, but with a 38 volt power supply and 180 watts potential output for a power amplifier, you are going down to 14 watts, and those 14 watts keep environmental temperature inside for a heatsinks between 55 and 65 degrees, closer to 55 degrees. And then it's excellent resilient system, and your total life cycle of such device will be about 10 years at least. When you go for 48 volts, temperature will be higher and electrolytic capacitors will suffer, and then the life cycle will be shorter. Who knows how much shorter, but it depends on the quality of the components. And looking to another variation, this is how I see second version. When you have RCA inputs and banana outputs, I would position this as a home cinema system, because you will have absolutely great 8-channel system, and you can use some existing receiver, or there are home cinema receiver systems without power amplification system, and then you can configure in different way. You know that 180 watt output capability for central channel and for left and right speakers with a good peak power capability will really sounds great. Yeah, will really sounds great. You can do several configurations. Also, you can make active speaker system if you want, and then you can use some digital crossovers. There are consumer digital crossovers and companies building digital crossovers. You have a full control over the speaker system. But I said I didn't find a reason to call for digital crossover. But yeah, with digital crossovers you can do the delays and many other stuff. Zero phase distortions. Because at digital environment we can do filters without phase distortion at all. Yeah, you can play a lot, but I recommend to start with a budget solutions. What else can you make? Yeah, you can make one more configuration, make balanced inputs and unbalanced outputs, and use professional active crossover for inputs, and have flexibility of consumer outputs and use existing cables. But definitely there's a risk to make a mistake, and for example make a mistake exchanging a woofer with a tweeter, and then you can burn a tweeter because you will run a power and you will not hear it. Yeah, because woofer is not capable to reproduce tweeter frequencies, and tweeter is not able to produce a woofer frequencies. You will hear a silence, you add the volume, and bam. Yeah, especially sensitive is tweeter, because woofer needs huge power. Yeah, in the music says bum or titch is 70 or 150 watts, and normally tweeter has just a few watts, and then you give 70 watts to the tweeter and bam, tweeter is dead. How about the pricing? We decided that we are aiming for 350 euro for integrated system without wires. It is very good price for 8-channel amplifiers at such quality and such power. The final electronic configuration will look like this. 2 boards, excellent power supply, high quality capacitor, and then there could be variations of connectors between the products, and the same is valid for such configuration. The same pricing, different boxes, and when you give your feedback about which one you like, earlier or later we'll convert one of those solutions into a product, but not now. And we decided that we will make a new product section. We will call it warehouse sellout, and then we place prototypes on that site for a good value for the money. Those will be technically perfect, but aesthetically unfinished. Those will not be painted, there will not be prints and many other things. You can save some money, and maybe there are audience who like really functionality, or you can paint it by yourself or do many things. But we will test, and this will be kind of market research. Those devices which has a high demand will convert in products. Those who doesn't will live a short life cycle and then will die. But I find out that there are people who are buying such unpainted devices, and they are aiming only for a technical perfection. and we will make devices without the compromises from the engineering point of view. And summarizing, I think future is for active speaker systems, because we can get by far better quality and by far better resolution for our speakers. And today's speaker is a weak point, and when you drive it actively and directly, it will sound by far better than you have solutions with a passive crossover in your speaker systems. And also it gives plenty of flexibility to modernize some old speakers, upgrade it, or if you upgraded your speakers and you have an old speakers, you can modify, and then you test and check. All those who like to play with equipment and find out the best possible audio quality, you can really experiment and find out that maybe upgraded budget speakers will sound better than very expensive speakers. It could happen just due to the physics, how you drive a speaker. And when we're talking about audio quality, it's all about how you drive a speaker. It's not about the quality of audio amplifier, because when you connecting speaker directly to amplifier output, it's very easy load. Any amplifier will perform. You will be surprised how good they be with a simple solutions, and by far better than very expensive amplifiers. This is the future. This is the right approach. This is better due to the physics, not better due to the price, or better due to some parameters like total harmonic distortions. No, it's a better architecture. And good luck with your projects.